collimated laser beam, and we get to a very high numerical, very powerful, a very strongly focusing lens.
These random scribbles you're writing, are these going to be meaningful to somebody other than you and other than us who knows physics? And
yeah, somebody will figure out that I've drawn this. You know, it'll have a narrow waist and a broad divergence. So
sexy.
So yeah, okay, so you basically have a very concentrated. The light comes in, then it makes a very sharp focus, and then it diverges.
Okay, that makes sense.
Oh, you think about light. So light is made out of photons, right?
Okay.
You can think of the light as being able to exert pressure. You can think of the photons being able to exert pressure. So you can apply. So there is a force. Like if I stick something into this laser beam, there's going to be, and the light's going up. There will be a force on whatever I stick here. However, it also turns out that. There's what's called an optical gradient force. So like basically, when you do the there is probably an intuitive way to explain it, and I just haven't thought of it. But basically, things. Okay, if I have like a particle, if this is air and I have a particle here, the particle is going to be attracted to where the light is most intense. The straightforward argument is you can start to draw some pictures about.
But what do you gain from attracting it to where the light's most intense? Or
you can pick things up.
Like what?
I can pick up a micron-sized particle and move
You're
it
picking
around.
things up with light.
Cool. You're moving stuff around.
Okay, this is not
But
new.
what does that accomplish for you? Moving stuff around with light.
You can, like, for instance, let's say you have two particles that interact with some force. You can pull on one into and see how much force you have to exert to move it away from another particle. Or let's say you have, or the experiments like this guy over here does. Let's say you have like a particle like that's like you have an oil-water interface, and you have a particle that's in the water. You want to know what forces are exerted by the interface on the particle. So use the optical tweezers to try to drag the particle.
How long until you solve the issue that by studying things you change them?
This is classical mechanics, so I mean, this is
That's
relatively
not the issue. That's the
non-perturbative.
truth of the universe.
Okay, I mean, this isn't quantum optics, but like, you worry. Yes, there are things you worry about. It's more for us. It's more chemistry that we have to study.
Yes, you have to take that into account. You have to take.
So yeah, we do have to take into account.
I'm messing with them all over.
Yes, I'm also recording this, by the way, guys. So.
No, you are.
Yes, I'm not. Yes, I am.
Okay, so alright, so this laser is actually relative, enough to hurt you. If you get this trapping, I'll show you what's. So the trapping beam actually comes in. It comes in from an optical fiber. So just don't. And too close, but like it comes in over there. That yellow cord. That yellow cord's an optical fiber, and then it goes into the microscope. Off this mirror, and then comes up through one of the objective lenses. The little laser itself, I will take the trouble of opening this up. Just try not to, sneeze it or anything.
Try not to break it.
Don't put your gum on it, Russell.
So how much does this sucker cost?
It's like $1 million.
The microscope is probably 50,000, 50 or 80,000.
You're off by order of magnitude.
No, I'm not. I've had it.
No, this guy was.
Oh, I said $1 million. Just a hyperbole, but.
Okay, so the badass laser is actually relatively badass laser is in that thing right there. It's a little it's a semiconductor diode, so it's cylindrical lens to collimate.
How delicate are these things?
They're delicate.
Delicate. They're delicate because has to be aligned very carefully. So yeah, it's all glass. So yeah, it's easy to break. Or you touch it, you'll get it'll be a pain in the neck to try to clean off the fingerprint grease.
So if you were to break it, what would your boss say?
It happens. I mean, you break. My boss. I once came into him when I was. I had recently joined the lab, and I was like, oh man, I broke blah blah blah, and oh yeah, don't worry. If you're not breaking some things, you're probably not working hard enough. So no,
that's true. It's a see again.
Okay, so I'm moving close this back.
It's a very Malthusian way of looking at it.
Yeah, so this is a coupling into the fiber right there, and that's that fiber that right. Okay, that's enough. Okay, really, no, that's quite enough.
Okay, that was cool though.
Yep.
Okay, seriously, let's not. That's okay. Let's not do it. No, let's not have any practical jokes. No, right? by the data.
The expensive
Both of us
equipment.
are all counting on to get data, so. Okay, so. Okay.
Jerome, maybe we should just go back to the
I think
before we
so.
break anything.
Yeah,
It's getting late anyway.
Yeah.
Okay. Thanks.
I have ADHD and